All right, I think we'll get started then. Good afternoon, everybody, and welcome to the first SMI lunchtime webinar. And this is a new experience for a number of us, and we hope we really have a good afternoon session. As you're all aware, we're adapting to a life of working from home. We've initiated the webinar series to keep you up to date with the research that we are continuing to do here at SMI. Just in terms of a little bit of procedure, during the webinar, you'll notice at the bottom of your screen, there's a question and answer button. And if you could press that button and pop questions in as the webinar continues, what will happen is we'll pick up those questions, and at the end of the session, I'll then read those out for Claire to answer. But please feel free during the webinar, if you've got a burning question, pop it in there. We capture it, and then we will answer those questions towards the end. So it really gives me great pleasure to introduce Associate Professor Claire Côte, who's the new director for the Centre for Water in the Mining Industry, CWiMI, and group lead for the Environmental Excellency through the mining cycle, and an opportunity for her to discuss her work in erosion and sediment control this afternoon. Claire has over 20 years experience in environmental and water resource management for a range of sectors. She's held a number of roles in research and consulting engineering, and along with my predecessor, Chris Moran, set up the SMI Centre for Water in the Minerals Industry in 2004. Since then, she has worked for the mining industry in Australia, Africa, Chile, Canada to address water and sustainability issues, and documented and implemented leading practices. And we're absolutely delighted that she has returned to work at SMI late last year, and even more delighted that she accepted the role of Director of CWiMI February this year. As I said, after the presentation, there's an opportunity for Claire to answer some questions, and really now it's just an opportunity to me hand over to Claire.
Thank you very much, Neville, and thank you for the kind words. And it is wonderful to be back at SMI. Welcome everybody. Thank you very much for dialing in. I know we are spending a lot of time on video conference at the moment, so I do appreciate the time. I try to keep the talk a bit light-hearted. Today is a nice change from all the discussion about viruses. We will not mention the virus today. We'll be talking about water, and specifically water in mining. And I've got a slightly facetious subtitle, Don't Forget the Rain, because I spent a lot of time in my career talking to auditors, a lot of auditors and corporate level managers who, when it comes to water in mining, seem to focus a lot on access to water resources for production. It's really important we don't forget the other side of the risk assessment, which is dealing with the environmental risk posed by water in mining, the impact of mine-affected water on the receiving environment, and part of the key contaminant of interest is sediment and turbidity. And there's quite a lot of work that needs to be done on erosion and sediment control. So that's the topic of my talk today. Just a brief high-level overview of issues we deal with related to water quality in mining, and the sort of work at SMI we are doing to try and address them. So as I was saying, a bit of background, water in mining covers a lot of topics, from access to resources for production to impact on the receiving environment. But a lot of discussions in the public domain or in water strategies in auditing, they're quite obsessed, really that's the word, with water availability for production. It's driven by specific aspects which are perfectly understandable, but mainly is driven by operations that require huge volumes of water. And when I say huge, I mean it. So there are examples of, say, one copper mine in Chile that would require more water than the entire coal mining sector in Queensland. So there are operations that do require access to large volumes of water. Sometimes they are located in arid areas, so it makes that requirement even more difficult to secure. Or they are in jurisdictions that have inadequate water resource planning. So if you don't have a good government process to allocate water resources to the various users, then yes, of course, you might run into trouble for securing your water access. But I find this focus on these specific operations, they tend to skew the risk assessment towards water access. And it's really important we don't forget the other side of the coin. And if you look at approval process, so if you're trying to set up a new mine, if you're in a jurisdiction with good water resource planning processes, securing an allocation for water is not a difficult nor a time-consuming process. However, securing the licenses and permits you need to manage your runoff, that is difficult, that is time-consuming, and there's no guarantee you will secure that approval. And most of the studies will focus on that aspect. So let's try and stay aware of the range of issues the mine can face with respect to water. It's not all about access to resources. And to illustrate this, let's look at the BHP Water Report from 2018. So BHP, I'm pretty sure it's 2018, they produced what they call their inaugural water report. It is a great report, a fantastic publication. At SMI, we are very proud of it because 10 years ago, we developed a water accounting framework for the mining industry. It was in response to a lack of consistency in the sort of information the industry was producing in relation to water. So we sat down and set up that framework and then worked really hard towards implementing it. But we were heavily supported in that endeavour by BHP, who straight away made the commitment to implement the water accounting framework at all of their operations around the world. So 10 years later, they have this amazing data set about water, and they've compiled it all and used it to produce that water report. So it's a fantastic source of information. And having that data allows them to do a very complete risk assessment on their water risks. And they've compiled them and published them in that water report. They look at a range of water-related risk. If you look at water security, which I'm showing in green here, you'll see, as I was saying, it's actually not that many operations. We've got Escondida, big surprise, copper mine in Chile in an arid area, of course, water security is a risk. Olympic Dam, quite a similar setup, really. The advantage that water resource planning process, we hope, is a little bit more advanced in Australia, but there's competition for resources for sure. And then just a few others, mainly related to climate variations and risk of drought. But then we go straight into issues around water excess and dewatering, too much water, extreme weather. So yes, this drought is included in this, but a lot of it is cyclones and floods. Almost a lot of the operations are at risk of these. And then environment, impact on the receiving environment. Every single BHP operations is concerned with that risk. So in terms of hierarchy, you can see impact on the environment remains a core water-related risk that operations need to manage. It is pretty much everywhere. What makes it a bit difficult in terms of addressing those risks is regulatory frameworks vary a lot around the world on how best to deal with that. So the release of mine-affected water, so any water that comes in contact with mining activities, it will be heavily regulated, but the way governments go about that will vary enormously depending on your location, the climate, the weather, a range of aspects. There can be differences between state and federal regulations. We see that in Australia. Canada is another one where there's a range of legislation, some at state level, some at federal level. Canada is a good example on that topic because there's quite a lot of water, obviously. Access to water is hardly ever an issue, but environmental issues related to runoff flows are very, very prevalent and heavily regulated. And it can depend on the commodity. So in Canada, they have different rules, whether you're a coal mine, a diamond mine, or a metal mine. The metal and diamond mines have specific effluent regulations to deal with the stormwater flows, but coal mining is regulated mainly under the Fisheries Act because of the potential impact of mine-affected water on local species of fish. So there's a huge range of permits, licenses, regulatory issues to deal with, and it very much depends on your local context. And that's what makes it a bit hard to address on a global scale. So at SMI, we have the Complex Ore Body Program that Rick Valenta is heading. And we are developing some high-level scoring of environmental and social risk. And with water, we focus mainly on access to water because it's quite easy, or it's reasonably straightforward to come up with a proxy that will capture your risk. We use rainfall, climate variety, these sort of aspects, and then we come up with the ranking in terms of your risk of not being able to access water. If you try and do the same thing with potential impact on the environment, it's a lot harder because it is not obvious which proxies you should use because of the huge variation in regulatory frameworks. So it's not impossible. It would be obviously quite exciting work to do, but it will require a lot more resources. And we're definitely starting to look at these aspects. When we're looking at mine affected water, we're looking at the key components, the key contaminants they will contain that might pose a risk to the environment. Critical ones are sediments and suspended solids, and it's all around. They can be a major cause of ecological degradation if freshwater ecosystems smothering everything, reducing oxygen availability, etc. So it is absolutely critical to manage them and ensuring we don't export to a load that isn't acceptable. Salinity, that will vary with regions. I'll be talking about Queensland a lot today, and in Queensland it is the key aspects from coal mines. Anyway, they do generate quite a lot of highly saline water. And otherwise, the standard culprits that you've all heard about, pH, sulfate and metals, all the contaminants associated with acid mine drainage. There's enormous body of work on this topic. I'm not talking about this today, but it's good to be aware that it's just forms part of those environmental risks we try and manage. Now, surface water management, the general principles, they are well understood, but the devil's in the detail, and it can generate an enormous amount of work. So if you look at, say, an environmental officers, environmental managers on a mine site, they will spend very little time worrying about water for production. But in some operations, the time can be entirely consumed with dealing with water flows. The general principles are quite straightforward. We segregate mine-affected water from non-mine affected water. So we create diversions as best we can around a mine site, and then we collect the mine-affected water in complex drainage network, and then we decide on where we put this water. So there's whole issues of containment. Once I've collected the mine-affected water, do I need to contain it? Do I need to make it go through temporary structures? And that will vary depending on the jurisdictions, what the expectations are, and what the requirements are for the receiving environment. So there's a range of engineering design, engineering criteria, depending on the licenses, the permits, and the regulation. It requires very strong technical skills. There's a lot of spatial analysis, looking at your catchments, looking at your land use. How can I design my drainage network to be as efficient as possible? There's a lot of engineering work, not only at the design stage, but the implementation as well. We were talking about Canada. An operation in Canada, in Northern Canada, can spend the entire time just managing the drainage network, repairing defects, monitoring what's going on. It is a lot of work. I cannot emphasize that enough. And then there's the controls, and a lot of the controls is around water quality monitoring and the receiving environment. So almost every mine does that. Every mine would have a monitoring network. It does generate extensive data sets, and that's the amount of information. So as researchers, of course, for us, access to that data is precious because that's what gives us the data we need to look for improvement, propose new approaches, etc. So a lot of work on managing those flows. And why do we do this? Obviously to preserve the receiving environment. So because we're going to be talking about erosion and sediment control today, I'll focus on those contaminants, sediments, which tend to be, one way to measure them, particularly in an automated monitoring network, is to measure turbidity. Turbidity is a measure of, what can you see through the water? Is it crystal clear or is it quite turbid? The unit is NTU. So in some environments, we're dealing with freshwater ecosystems that are crystal clear. These photos from northern British Columbia, and standard NTU measurements in those streams is 20, 30, 40, which is pretty much nothing. Crystal clear water. And the limits that imposed by regulation would be around 80, 90, 100 NTU, a very, very low number. So they have to manage their runoff to ensuring they maintain that purity in the water. So it is very challenging. If you look at the other opposite, which would be Queensland, there has been so much land degradation in Queensland, and nothing to do with mining. I mean, a lot of it is just the general catchment degradation. The mines have turbidity monitors in the streams, upstream, downstream of the operations. The maximum number a turbidity monitor can measure is around 4,000, it's 3,600. Anyway, as soon as it rains, upstream of the mine will be at that maximum level almost straight away. And the streams are completely brown, an enormous amount of sediments being exported. Mining, I will emphasize this again, is a tiny, tiny, tiny contributor to that total load, but it still needs to be managed. And the things that make it hard, there's two aspects that make these particularly challenging, is the climate and the weather. So the climate is the general context in which you operate, and the weather is the daily variations that will influence your management strategies. That photo was taken in August in British Columbia, and the day after we got this weather. So a massive snowstorm, and then suddenly you've got peak flows that you've got to manage. In this context, they have large sediment basins, so that's the photo on the right, that capture the runoff from the mine-affected drainage network. The water is allowed to settle in those basins, and then it's passively released to the environment. If it's not successful, so if the turbidity measurement downstream is still too high compared to the limits, then they will add flocculants, the chemical they add to the basin to make sure the sediments settle, so that the water that does overflow is suitable to the receiving environment. And then the additional fun to this, of course, is those flocculants can also have an impact on the fish. So you've got to do additional monitoring to make sure you haven't impacted on the fish. So when it rains or when it snows, it's all hands on deck, and there's absolutely no spare time to do anything else. So the weather is a big impact on teams, on safety, on resources. So it's really important to understand the level of risk so that adequate resources can be appropriately allocated to the work that needs to be done. Let's go back to Queensland now. So we're talking about climate and weather. Queensland is all about climate and the long-term variations. You know how it works. Southern Oscillation Index. We go from El Nino to La Nina. So we either have drought or we have floods. And when we have floods, it's a lot of water. I like talking about these just because the floods we had in 2008 and then 2010 and 11, they were the trigger for the new regulation we have around water management on coal mine sites. So they're quite important events because that's what sets the requirements for the new rules. So the biggest event we had to start with was in 2008, where a mine next to the Nogoa River flooded. Some of the pits are located in the floodplain, and they are protected by a levee, but the flood actually overtopped the levee, and then the mine filled up. Then they got special authorization to pump a lot of that mine-affected water into the river. So mine-affected water in Queensland is saline. So it's got electrical connectivity around 10,000. So it's about a tenth of seawater, roughly. You definitely can't drink it. It is very salty. When they did pump all that water back into the river, there were a lot of complaints from the community and downstream users. So they realized that just was not acceptable in the long term to keep continuing or to manage mine-affected water that way. And then, of course, 2 or 3 years later, we had the floods. So that led to a very thorough engagement process between industry and government to draft a new regulatory framework for dealing with mine-affected water. And Queensland is quite different from other jurisdictions. It uses the concept of mine-affected water and non-mine-affected water, and then the management strategies are quite different for both of them. A lot of it is driven by the climate for a start. So it's not with the rainfall that we get in cyclonic events, in the Fitzroy catchment where almost all of the coal mines are located, you can't contain all the runoff generated by a cyclone. So you've got to find practical ways to deal with this. The scale of disturbance as well. So those strip coal mines, they can disturb a large area. So you've got to manage runoff in a much more practical way than you would in a small metal mine somewhere else. So that's where it's coming from. So mine affected water has been in contact with mining activities, and it must be stored on site. And a lot of those coal mines, the strip mines, they do have voids that are not active anymore and can be used at water storages. That's what makes the mine water system so complex, because they have a lot of storage and they can have a lot of water in those storages, and they've got to manage that. And that's where the site-based water balance modelling that SMI has a lot of experience with. We've been driving a lot of improvements in the development of those mine site water models. That's where that expertise comes in. And then the non-mine affected water, it has not been in contact with, say, your pit. It's just the around the operations. And that can be quite a huge area. So it can generate large flows. That can be passively released to the environment as long as sediment content is controlled. And we do that through implementation of what we call an erosion and sediment control plan. And the aim of this, so this is water that's not saline. However, it can be turbid. So it needs to be less turbid before it can be put back into the environment. The photo under this is the sediment plume that went out to the Great Barrier Reef after the 2011 floods. It is heartbreaking. It's all that, and this is a resource as well. I mean, this is the topsoil from the Fitzroy catchment being exported to the sea. So you've lost your key land resource and you're smothering coral, which isn't a bad shape anyway, but certainly that's not helping. Again, mining is just tiny, tiny, tiny contributor to that plume, but still we need to try and manage it best we can. So important to manage sediment loads. What happened after the flood is this amazing initiative as well, that I think we don't talk about it enough because it's such a great achievement. There were so many concerns about water quality in the catchment after the floods that there's a new initiative was set up. It's called the Fitzroy Partnership for River Health. So the major industry catchment groups, etc., dealing with the Fitzroy catchment, got together to discuss water quality issues. So it was a real catchment-based initiative. The ICMM recently released a water stewardship framework, and they make it clear they want to adopt catchment-based approaches. This is the best example of a catchment-based approach ever. And we haven't really seen anything else in the world that comes anywhere near this. So all the actors in the catchment got together and they decided to compile all their water quality information. I was mentioning the data sets that were being generated through monitoring. So those data sets were put together, and the aim was to produce a water quality report card. So look at the data. What does that tell me about my water quality in the catchment? And I'm going to give it a grade. And that process of giving a grade is done through a scientific committee. So the Partnership for River Health is the users together. They have a committee, and then they've also created a scientific committee to look at how to turn that data into those grades. CWiMI from SMI is a core actor in that scientific committee. So SMI has had a lot of input into this through CWiMI's participation. What this has done as well, the whole process of putting the data together, it just did raise a range of issues around data management. So there's been a huge step change in data management processes. And 10 years ago, everybody had PDF files on their computer somewhere, and not anymore. So what's happened is the mines and the corporate offices set up huge environmental databases that can feed straight into a regulator's database. So the regulators stepped up as well. And all those processes are quite automated. And then that regulator database data can be provided to the Fitzroy Partnership. So yes, fantastic catchment-based initiative, but also a huge step change in some technological aspects. So it's fantastic outcomes from this. and it gets better. So there's now 8 report cards. It doesn't really change much, the grades. It's really driven by the weather. So dry years, wet years, and that's where you're going to see differences. But otherwise, it really is the key contributor. But what's happened by plotting and looking at all that data is people realize most of the data was coming from mine sites. And mine sites are located in parts of the catchment that are quite isolated. The creeks are not permanent water bodies. A lot of them are ephemeral streams. We had massive amounts of data in parts of the catchment where it actually didn't matter, and no data in the part of the catchment where it actually mattered, and we would have liked to have data. So what the industry is doing at the moment is looking at changing the way they go about their monitoring and trying to pool their resources to set up an integrated monitoring program that will be targeting permanent water bodies and will give us a much better vision of overall water quality in the catchment. So rather than having heaps of data in isolated spots that happen to be near mine size, trying to do something for the whole of the catchment. At the moment, they have to do, there's a requirement in the permits that they have to do some receiving environmental monitoring. So instead of spending that money on that component, they can pull their resources into an integrated monitoring program. It's progressing really well. It requires adjustment of permits, and that's what's taking a while, but it will happen. It will be an amazing contribution, an amazing catchment-based initiative as well. So there's a bit of background about the Fitzroy Partnership for River Health. In terms of the data, there's quite a lot of data it generates, and obviously sediment is in there. That's what I'm showing here. It's for the Mackenzie River. Result will be about the same, and then public catchments, the Fitzroy is degraded, and sediment's a big issue. So the other aspect, of course, is the Queensland Government looking at water quality issues that impact on the Great Barrier Reef. So I could make a little comment here about the fact that the main impact on the Great Barrier Reef is sea surface temperature and coral bleaching, and looking after water quality is something we've said this for years. They've never done anything about it, but now they find that it's a quite nice distraction from actually dealing with climate change. But anyway, we've been asking about some more action on water quality, so we'll take that. It's a good initiative. They've set a very strong target for sediment reduction, so that's a positive. Again, mining is a very small contributor, but it needs to be done properly. There's obviously Queensland, not only is the rain all over the place and very heavy rainfall events, but the soil types make it very difficult. There are a lot of what we call dispersive soils and spoils. Dispersive soils, and then of course the spoils will be dispersive as well, so the waste material from excavation. They are super susceptible to erosion, and we're talking gully and real erosion, so very serious export of sediment from this type of soils. And that's where soil science remains a core component of environmental work in the mining sector. So at SMI, we have a strong skill set in soil science because it remains a core component, both for rehabilitation planning and management of water-related risks. So we keep investing in this area. There are fewer and fewer soil scientists around because government departments do not invest in them as much as they used to. So it's a bit of a dying skill set, and SMI retains that very strong skill set, and we are very fortunate we've managed to maintain that expertise. So there was a lot of work done on the Queensland regulatory framework, and we got to a place that's good and is practical, but the regulation is quite confusing in what constitutes mine affected water and what isn't. And people are quite confused, so they try and do the right thing, but they might not always assign the right type of water to the flow they deal with. So we saw that there was an incident, I think it was last year, where BHP got fined quite a lot, a big fine for export of water to the environment. And when you look at the press release, clearly people have no idea what they're talking about, because they say they release mine affected water, but then straight away they talk about silt and sediment. So if the water quality issue in your water was only silt and sediment, it was non-mine affected water, is your erosion and sediment control plan that wasn't effective. Release of mine affected water, it refers to water that's held in storage in pits that you then pumped out to the receiving environment. So there's a lot of confusion, not only within mine site, but I think in the broader sphere about how we manage water from coal mine sites. The mines are committed to the erosion and sediment control process, but they are a bit confused what constitutes mine affected and non-mine affected water. And they need a lot of the issues as well is a lot of techniques to deal with sediments. They come from the urban sector and they're not applicable to the scale of disturbance that comes from mining. So we really need to have a better look on how to do effective erosion and sediment control on those Queensland coal mines. And that's what we're going to be doing. We starting a project financed by ERCAP, which is developing an erosion sediment control framework specifically for the coal mines, the Queensland coal mines. So first, define clear objective for the ESCP because it hasn't actually been defined. So we just know non-mine affected water needs to be managed by one, but we don't really know what the objective is to be. Is it a specific limit on turbidity? What is it? So we'll have to do a bit of work on that. A lot more guidance on how to analyse your stormwater flows and deciding what is mine affected, what isn't. And we'll be using all those water quality monitoring data sets to help out with that task. Some tasks on mine sites, it's easy to see, it's easy to control, so we'll provide a lot more guidance on how to do it. Again, a lot of the information at the moment has been developed for the urban sectors, they can't really use it, so we need to readapt this and make it mine specific. Some mines are old and they've got old disturbance and that generates a lot of flows and you can't really go back and control every single one. So we need to come up with a risk-based methodology on what is it that needs to be treated, how do we go about it. So a bit more guidance on dealing with the old sites and old disturbances. And then the core research area will be on sediment basins. That's my next slide. I'll talk about it next slide. And then we'll be doing a lot of training, obviously, of key interest groups. So mine site personnel and consulting engineers as well, who ultimately are the ones designing the erosion and sediment control plan. We're looking at pathway towards accreditation as well. So at the moment, anyone can say, yep, I can do your ESCP. So we need to provide a bit more confidence to the industry about who can do it and who's got the skills to do it. Sediment basin. So for a mine, that ultimately that's going to be probably the best way to deal with large runoff flows that contain a lot of sediments. The design of sediment basin, the instructions to do the design, it comes from the urban sector where you've got small disturbance, soils that are not particularly difficult to deal with, and streams that are not ephemeral. So you collect the runoff flows, you let it settle for 1, 2, 3 days, depending on what you deal with, and then you passively releases to the environment. Now you try and do this on a mine site, you've got huge disturbance, dispersive soils, so you generate a lot more sediments. So your basin is going to have to be bigger to start with. And for what event do we design it for? We don't really know. And then by the time if you do a bit of settlement over a few days, by that time, the creek has stopped flowing most of the time. So, and we don't want to change the hydrology of those creek systems. So we don't want to be putting water in them where they're not supposed to be receiving water. So there are a lot of research questions just on that topic. And the key research component of this ERCAP project is around the design of sediment basin. And this is not just in Queensland. We got actually doing the exact same piece of work in New Caledonia. Very similar background. Sediment's the key contaminant of interest because there's nickel mines in New Caledonia. They drain to a lagoon with coal, so sediment's not a good idea. It's very red too, laterite, so it's not a good look. They're subjected to cyclones. Sediment basins are the key controls, but again, and you see them on those photos, it's quite clear that's what they're using. How do you design them? And the key issue there is they're in the mountains, so that adds a layer of complexity to the designs of those structures. So we are starting a project in New Caledonia with French partners, and we'll be looking at exactly very, very similar issues. We'll be comparing all the regulatory frameworks, reviewing the mine site environmental management plans, looking at the data that they collect, and propose a modelling framework to help out with the design of those sediment basins. So it's a very nice little overlap between the two projects because very similar objectives but very different contexts. So it'd be really interesting to see what the results produce. All right, so I'll just conclude. I hope everybody's still awake. So stormwater runoff, don't forget it. So mine water related risks, they are a range. It's not just that water access, there's a range of risks to manage, and stormwater runoff is one of them. It is challenging and will be a lot, it is very context specific in terms of climate, weather, geology, contaminant of interest, environmental values in the receiving environment. So there's no one size fits all. And that's why we have such a wide range of regulatory frameworks, because they are adapted to the local context. What's going to make it a lot more difficult is climate change. So all the design criteria that we have at the moment, they're for historic data sets. And what we find is that it's becoming less and less relevant because of the weather events we see coming through. So I was showing a photo of a mine in northern British Columbia earlier. It used to be that, you know, the critical water management issue there is when the snow melts. So you basically store water for a couple of months during winter, and then it starts melting, and then you manage your melt flows. And it used to take 6-8 weeks for the snow to melt. Now they've got peak in temperatures early in the melting season, and sometimes now the snow melts in 2-3 weeks instead of 8 or 10. So your peak runoff flows are increasing. It's becoming more and more difficult to manage those flows. And it becomes quite impractical to design control structures to deal with those magnitudes. So this is raising a lot of research questions that we are very involved in around enduring design criteria and the impact of climate change on them. But obviously there's strong opportunities for research at SMI on that topic, predicting the impacts, the design of the control measures, and potentially treatments as well. So it will remain a core activity from within the SMI. Thank you very much.
All right, thank you very much, Claire. That was incredibly interesting and very, very topical. I've opened up the question and answer session. So if you have any questions, please go onto the box at the bottom, pop in your questions, and then I will moderate those and pass that on to Claire. At the moment, I have no questions. So I don't know whether that's because I've explained how to ask questions poorly, or Claire, because you were absolutely clear and there were no questions in terms of what you're looking at. But maybe while we wait for people to type and get some questions in, I was very interested just to get your perspective on other jurisdictions. So you've spoken about Queensland and particular challenges there. You've spoken about Canada and challenges there. One of the areas we're interested in as well is Chile, and having a look at the challenges in Chile. I don't know if you can comment on anything that's particularly unique that they're dealing with, that it gives us another view, another data set.
No, so obviously from the arid areas, there's going to be very, very little stormwater runoff. And I think when there is, they would be keen to contain it for future use. Where it rains more, so south of Santiago, there doesn't seem to be much of an issue. They do the receiving environment monitoring, very, very similar, but they don't seem to be generating concentration contaminant of interest that pose a lot of risk as far as I've seen. But I haven't seen many data sets, so it could well be that I'm not completely on top of it.
All right, I have a question, and the question is, where's the best resource to find a good definition of mine versus non-mine impacted water? And is there a Queensland guideline?
No, there is. That's why we are doing this project. There isn't. So the definition I provided in the Environmental Authority, the government does provide a definition, is very vague and very high level, and really is not enough guidance to be comfortable with the outcome you get. So hence this ECA project. This ECA project came after a few years of consultation with industry, understanding the gaps, and that is the key gap, is no one really knows how to call it. So give me the guidance on clearly outlining what is mine affected and what isn't. It's going to be based on land use. It's going to be a combination of land use spatial analysis and water quality monitoring.
Right, thanks. And then, I mean, but in terms of the definition of the two types of water.
So in Queensland, they're providing the environmental authority.
Okay, so because you did give some guidance in the talk on the two, but it's whether there's a definition that is.
So the only definition we have in Queensland at the moment is that provided in the environmental authority.
Okay, good. And then Claire, we've got two questions about flocculants. The one really is talking about the impact that it has on water chemistry.
Yeah.
And then the other one is whether there are biodegradable flocculants to manage coal fines in dams. Yeah, I don't know if you've got any views on that or any experience.
Well, they're used, but so a lot of in coal mining, they tend to use the flocculants for tailings to try and dewater the tailings before they put them in storage. And these are fine, and they're part of the mine-affected system anyway, so they don't pose a massive threat to the receiving environment. And they assure me, I mean, the suppliers assure me they are biodegradable. We've never picked anything. I mean, I've never seen an example of monitoring showing that there's an issue with them. But again, they're part of the mine-affected system anyway, so we probably wouldn't pick it up. The flocculants the issue we have here is dealing from an erosion sediment control perspective is dealing with the dispersive soils. And that's where the use of flocculants becomes a bit more problematic, and they don't always work, and depends on the size of the basin. So we'll look at that when we are looking at the design criteria for sediment basins.
Right, and I'm pretty sure we've got a number of flotation chemists in the JKMRC that could probably give. Unfortunately, I don't know who the person asking the question, but if you drop me an email, they'll probably give you quite a lot of information around different flocculants and their composition and their degradation.
Yeah.
So yeah, if you drop me an email, I'll get you a detailed answer on flocculants if that's helpful.
That's great.
All right.
That's really good.
So this is the last chance for questions. If there aren't any more, I'm going to just give a minute or two in case you're typing, because I'd hate to cut off too soon. All right, is there technical guidance relevant to erosion and sediment control for mining, or is this covered under the EA?
Yeah, no, there's no technical guidance. So, and they're all the books they refer you to, they're all from the urban sector. So they say, oh, there's a what's their name? International Erosion Association, whatever it is. There's a lot of information on that. It's all from the urban sector. The mine site personnel do go to training, and it's always run by people from the urban sector. There is no guidance specific to mining. New South Wales has taken a slightly different approach, much stronger, with hardcore limits, and they provide very, very strong guidance. So you must do it that way, you must design that way. So New South Wales has a bit more information, but it doesn't quite match the Queensland conditions. So you can't, it's not really appropriate to apply the New South Wales rules in Queensland.
Right, thank you, Claire. All right, I think then I will close the session just by thanking Claire for, oh, hang on, here's another question. I'm just about to thank you. You're going to get at least 6 thank yous out of me, Claire. Is there generally an accepted capture runoff from linear infrastructure?
Sorry?
So is there generally an attempt to capture runoff from linear infrastructure?
So the containment of runoff, it really depends on the local context. So it's all around that concept of mine-affected versus non-affected. And the containment requirement will depend on your permits and your local regulatory framework. So in Queensland, they've got to store it, the mine-affected water. So there's a lot of drainage work happening to make sure it drains back to pit if it's mine-affected. There's a lot of work on that. I'm not sure whether that is the question.
So I think there was a bit of clarity added to the question, because I wasn't sure what was meant by linear infrastructure, and meaning roadways. Ah,
that's the big one. So that's the key issue of contention, is the drainage from roads. That we'll look at that. At the moment, it's reasonably well accepted that road drainage goes to the erosion and sediment control plan and passively released to the environment. Now, in Queensland, they use mine affected water for dust suppression. So they do apply salt to the roads. So there is the issue of salt remobilisation, and it's actually appropriate to manage those runoff flows from roads through the ESCP. So what we'll do here is look at the monitoring data. So if you don't pick up anything, because it's huge, so imagine controlling runoff flows from every single road on a mine site is gigantic. So the approach here is the risk-based methodology and looking at the monitoring data. Are we actually picking up any issue? So far, so good. I haven't seen any example of a road contributing a salt load to the environment, but we'll go through that process again.
All right, fantastic.
Neville, just before you thank Claire again, I had a question. I thought this might open a can of worms as well. I mean, you mentioned that the feeble attempts of the complex ore bodies program to really define probably in a very overly simplistic way water-related risk, in which we just used regional data sets like the aqueduct data set. But if you were actually going to go about in a jurisdiction like Queensland, for example, if you were going to try to spatially map water-related risk for mines, what sort of measures would you want to get? What sort of proxies would you sort of define to do that?
So one, they're not feeble attempts, Rick. It's a good starting point, and in terms of water access, it was pretty good. And I did discuss this with the team, but I scared them away. They said, no, let's just do water access. It's getting too hard. I think it's doable, but it needs to be a lot more granular. So because yes, you need to take into account the water, all the water aspects. So I think yearly rainfall and variability will be two key climate components, but you need to look at jurisdictions. So how far down do we need to drill down? I'm not sure. So ideally state level would be quite good. And looking at trying to come up with a risk just for mine affected water export, I think it's doable, but you have to get the level right. And some jurisdictions we know quite well where the issues are, because it's not it will depend on geology and contaminants of interest as well. So you'll need several layers. So nothing the EGI system can't handle, just resources, I think. And a lot of the data will have to come from ahead. So our knowledge of regulatory framework, and that's part of an issue. That's a bit of an issue as well. So maybe we should, I think there's an exercise probably that we should be doing is just mapping jurisdictions and regulatory framework to start with, and mapping contaminant of interest. And once we've done that, then we can collate it with the weather climate data, and then we should be getting somewhere.
All right, Rick, you have opened up a can of worms. There's a couple more questions, and I think we've still got about 10 minutes before we've used up our hour. So I'm happy to have the questions, so thank you. So the question is, what is the position of industry and regulators when it comes to water quality issues and future risks associated with legacy mines? So we're looking at abandoned mines, decommissioned tailings facilities. Are there any regulatory frameworks that have tackled these issues?
Well, they will be captured eventually by the residual risk framework. So with the new legislation on closure planning, at relinquishment, you would have had to calculate your residual risk, and water quality is like big. If you look at the unwanted events in the residual risk calculator, is almost all, not all, but a lot of it is related to geochemistry and water quality impacts. So the mines that are planning closure now, it will be captured. The abandoned mines, however, it's that we know the issue, we know where they are, and it's resources really.
All right, I'm going to attempt one more time, Claire, to thank you for your talk, and really appreciate you taking your lunch break to come and share the work that you've been doing. And as I said, we're absolutely delighted to have you back at the SMI and running the water centre for us. And we look forward to the work going forward. What I would like to do is just do a little bit of an advertisement. So we will be having these lunchtime seminars to share what we're working on. And the next seminar will be Nikki LeBranch from our Mining Safety and Health Centre. And she'll be presenting on respirable dust, removing the unknowns. So I look forward to seeing you all again this time next week, Tuesday. And thank you very much for calling in. We greatly appreciate your attendance.